Drum roll, everyone. And we are live. It's a pleasure to have you here with us again this awesome evening. Good evening, Africa. Good evening, the rest of the globe, wherever it is that you're joining us from. If you are in Accra, if you are in Lusaka, if you're in Lagos, if you're in Cape Town, if you're in Pretoria, I'm running through all the city names I know in Africa, wherever that you are joining us from Nairobi, from Mombasa. We'd say it's a delight to have you here with us again this evening. Welcome to the Web3 Mastery classes, where we be running you through 6 weeks masterclass, where we hope that will turn you into a Web3 master, right? Full caveat here. So when we say that we're going to turn you into a Web3 master, it is our hope that by the end of this 6 weeks period, right, you would have come from that place of zero knowledge to where you know enough to write smart contracts to deploy on the BNB chain, right? For those who have not been with us over the last couple of weeks, this training session has been going on for 3 weeks right now, and we are going the entire distance of 6 weeks. So, and during the course of this entire 6 week session, we are going to have amazing people join us to come teach us blockchain technology with a strong emphasis on deploying on the BNB chain, right? And like I was saying, this is the third week in the series. So, just a little bit of a recap before we go into the session today. During the course of week one, we had a session on introduction to blockchain and consensus mechanisms, and we had the privilege of having as our instructor that day, Busayo, who took us through the evolution of the blockchain, the particular problems that the blockchain aims to solve, and also consensus mechanisms, right? Where we learned about the various consensus systems from proof of stake to proof of work, um, and to the fact that BNB as a blockchain network relies on the proof of stake consensus mechanism to be able to like validate blocks and then make sure transactions go through on chain. So this in the second week, I had the pleasure of having a session with you guys where we got to learn a whole lot more about the BNB chain docs, and we got to learn a whole lot more about the various BNB chain infra services from BNB chains, smart chain, also referred to as BSC, right? And then we talked about the BNB Beacon chain, which is our governance layer. And then we also talked about BNB Greenfield, which is our data infrastructure layer. So it was a very interesting session. And we had a lot of feedback from members of the audience. And one of the actionable feedback was to have a session on security. And it's my pleasure to announce to you that we have worked on a course, and in due course would announce to you in our Telegram community how to when that course is coming up and then how to join, right? So and today we are going to get into the meat of our course. Last week I mentioned to you that the first week and the second week we are basically theoretical sessions, right? And this is the week that we are going to head into writing code. And from here on out, up until the end of our 6 weeks, we are going to be writing a lot of code. So if you are here with your PCs, you have made a very wonderful decision, right, to learn this evening. And because today we are going to be talking about setting up your dev environments with an emphasis of working with the Remix IDE and also an introduction to smart contracts. So without further ado, it is my pleasure to hand over to our instructor today. And ladies and gentlemen, drum roll please. Hello, Fatma.
Hello, Emmanuel. Thank you so much for welcoming me here to be an instructor today and to impact the knowledge of most of the blockchain developers. Even if you're not a blockchain developer, but you're based in Africa and you're interested in this technology, here's an opportunity for you to learn. And you are welcome all. And it's a pleasure to be your instructor. Thank you.
Thank you so much, Fatma. So if it's not much of an ask, a bit of an introduction, and then you can take it on from there.
Okay, so I am a blockchain developer, and since last year, I've been working as a developer relations engineer, and I'm based in Kenya, and I also have a background in software engineering.
Awesome, awesome. So, guys, thank you so much for being here. As always, you know the ground rules. If you have any questions, just keep them. Your any comments, just keep them coming in the comment session, and then this is real time. We'll be able to answer those questions at the end of the session. And while this class is going on, please make sure you code along. And thank you very much. Over to you, Fatma. Take it away.
Okay, thank you. So today, this is week 3. I'm going to take you through development environment. So we're going to use Remix. I will send the link over on how you can access Remix, which is going to be our IDE. If you're already comfortable with using Remix, you can use any IDE that you have in your PC. You can have Visual Studio Code, that is also okay. And we're also going to do an introduction to smart contracts. So basically, we are going to do stuff with on Solidity. I'm not sure if you've heard of that programming language or not, but even if you're still new to it, this is the time to learn and enjoy this session. You're welcome. Yeah. Okay, so we're going to have an introduction to Solidity and the development environment. And so we're also going to write a smart contract, and then I'm going to give you a breakdown of the structure of the Solidity smart contract and what it takes for you to write a smart contract and deploy it, compile it, and deploy it on Remix IDE. And then also, I'm going to give you an introduction to OpenZeppelin. OpenZeppelin is a library that is used in blockchain development and security. So I'm going to give you a brief introduction to Solidity and the concepts that are involved in the Solidity programming language. This is basically what I'm going to go through. Introduction to Solidity, then you're going to write a Hello World contract, and then you're going to use Remix. So this is going to be more of a fun and practical session. And then you're going to see how you can use Open Zeppelin and how tokens and contracts are developed using the Open Zeppelin library.
So, thank you, Fatma, for that introduction. While we are going to continue in a bit, right? For everyone joining us, again, a couple of ground rules. Please note that you can drop comments in the comment section, right? But more than anything else, we had want you to be actively present in this session. So what that means is that you have to have your laptops ready with you, and then you have to pay close attention, and we had appreciate if you would code along, right? So back to you, Fatma.
Yeah, so while you're looking at the Solidity programming language, this is basically what you're going to look at. This is what makes up the programming language. So we are going to look at value types, addresses, references such as arrays, data location, memory, storage, and call data, functions, how functions are structured, and mappings. So yeah, just chilling here. Let me show you the presentation. I hope you can all see the presentation. Like,
Yes, please go ahead.
okay. So sure. Right now, you're all wondering, like, what's this solidity thing that she's been talking about or we've been hearing? So, Solidity is basically a smart contract language. Like it's the language that can be used in writing blockchain applications, especially applications that are based on the EVM and the BNB type of chains. So Solidity is an object-oriented programming language, and we can also say it's a curly bracket type of language. As you can see here, like when you look at this code, all you see is lots of curly brackets. So this is how Solidity code is usually mostly structured. So basically, it's an object-oriented language, and when I say it's an object-oriented programming language, I mean that it uses the concepts of inheritance and code reuse by the use of libraries like the Open Zeppelin library that I just mentioned when I was introducing this week's session. So I'll take you through the layout of a simple Solidity contract and show you how it is. This one is a bit complex for you to understand. So let's just start from the beginning. Yeah, sorry for the delay. So this is a Hello World Solidity contract or Solidity file. So when you're writing Solidity files or Solidity programs, they usually end with an extension of .sol. You see, like when you write JavaScript programs, they usually end with an extension of .js, or when you write Python, it usually ends with an extension of .py. So this shows that this is a Solidity program. So when you're writing Solidity programs, like programs that are meant to run on the blockchain or decentralized networks, this is what the structure usually looks like. So the Solidity contract usually starts with this comment like kind of thing, this license, SPDX license. So this license is usually used as an identifier, like it indicates the license that the smart contract developer intends to use. So it's usually necessary when you're writing a smart contract to begin with this line, because if you don't write it at the beginning, it is going to throw up some errors. So it's really necessary. And if you're not intending to use a license, you have to indicate that it is unlicensed. So, like, this is the protocol that is should be used when writing Solidity smart contract. And then another thing that's really important is to ensure that you write the pragma statement. So, like, every Solidity program usually starts with this. Like, after the license, you write the pragma keyword with Solidity and then the version. So this 0.80 usually specifies the version. So this is usually the beginning of the program from here, pragma Solidity, and then you specify the version. So at the moment we are around version 0.90, if I'm not wrong. So it's good to use some of the latest versions because you keep up with the bug updates with the compilers. If you use some old versions, let's say you at the moment if you use version 0.40, you'll end up having some bugs which are kind of obsolete. Since this version is obsolete at the moment, you're on a version that already has some bug fixes which weren't existing before. And then another thing with Solidity contracts or Solidity programming, you have to start with also the keyword contract. So our file is hello world. So we have to write contract hello world. This contract is basically like how in object-oriented programming languages we have classes. So for us, since we are doing Solidity, it has to begin with that word, like that keyword contract. So, as I said earlier, Solidity is a Calibre's language. So, after specifying the contract and the name, you have to write these Calibreses. Like, this is the body of your contract. After the Calibreses, that's where everything concerning your contract gets in. That's where the functions, the variables, and everything to do with your smart contract gets in. So you can't write unless you're going to import it inside this contract. You can't write anything beyond this unless you have to import it. So everything that does any blockchain transaction, it has to get into the body of this contract. So the next thing we are seeing here is a function. So a function is what specifies what this contract is going to do. So it can retrieve, update, or delete some info on the smart contract. So according to this contract that we are looking at here, the main thing that it should do is we're intending to set a greeting, like send over a greeting, and then we're intending to retrieve that greeting that we have sent over. So before we get further into this function, according to what you're seeing here, there's this string public message. Yeah, this string public message. So this is what we call a variable. A variable is like a naming convention. You see, like Solidity is a statically typed language. You have to specify, let's say you are to specify apples. You just can't write apples because it doesn't understand what an apple is. And it doesn't know how that apple is going to be accessed. So like an apple is usually, the word apple is a string of characters. So like here we have message. A message is usually a string of characters. If it would have been a number, I would have suggested that, or I would have stated here that it should be an integer. So since this message is going to be a string of letters, that's why I I intended for it to be a string. And this part where it states public, it shows that um, this variable message can be accessed anywhere in this smart contract. So this is what a variable looks like. You're breaking down the structure of a contract bit by bit, and then you're going to go to the documentation and see all these things that we've been talking about here. And then The next part is the function. So we have a function to set a greeting. So like we are creating a function to send over a greeting. And then the function, the greeting that you're going to send, it's going to be a string since it's going to be characters like hello world. So we have to specify here that our input, whatever is in here is our input. So we have to specify here that our input is a string of characters, and this memory specifies where it's going to be stored in the blockchain. So it specifies that it's going to be stored in the memory. And then this part where we say public, we are trying to specify that this function is public, meaning that it can be accessed anywhere within this smart contract. If we intended for it to be accessed by maybe a specific function or it not to be accessed by any other function or any other part of this contract, we would have specified the visibility of it to be public. So this is what we call function visibility. And then we open up with our curly braces, and then we input what our message is going to be, and our message, it should be greetings. Actually, this should be whatever is going to be input here. So we've just given it the variable of greetings, which is equal to this message variable up here. So let's say when you go to, let's say this, when this contract is already created, there's going to be an input whereby you're going to input this, like a text field, whereby you're going to input this greeting, which is our argument here in the function. And then later on, if you want to retrieve this message that you've input, there should be like a button, which this button is going to be connected to get greetings. So when you press on get greetings, you're going to get the specific greeting that you input in your text box. So this is what basically this function get greetings is supposed to do. So when you're supposed to get input or get values from the blockchain, you don't basically have to necessarily specify arguments, like, because the arguments are what you input for you, like you're giving the data when you specify these arguments. But when you are to get the data, you don't have to specify arguments. So the only thing that you specify is what is to be returned. So what is to be returned is the same thing that you had here as a variable, which is a string, and it's going to be stored in memory. So even here, sorry, we have our function visibility as public, and saying that it is a view function, we are meaning that this function like it promises not to modify the state of the blockchain. So if we were to like add numbers, you see that is a function that has to change. Like it's modifying the state of the blockchain, because every time you're adding a number, the input is going to be different. But here the input is just going to be the same, since we already just inputted it as our greetings, let's say hello world. So we are just fetching whatever we've input, and there's no changing or there's no modification of the blockchain. That's why we specified that it's going to be a view function. And then here we have to return. Let's say if you have to fetch data from the blockchain, your function has to come back with a return value. So you have to return the message that we had specified earlier, which is going to be our hello world message. Okay. So this is basically the structure of our smart contract. So we are going to go. Next, you're going to go to the Solidity documentation, and we're going to look at different data types that are involved and that are making up the Solidity programming language. I'm sure you've heard me talking about variables. So right now we are going to look at the different data types that make up this programming language that is used on the blockchain.
Yeah, we can see the comments. Thank you very much for everyone who is here joining us, wherever it is that you're joining us from Africa. And for those just tuning in, I hope you are right by your PC. It's a delight to have here with us Fatma, who is walking us through an introduction to Solidity. So it's our hope that even by the end of today's lesson, you will be able to write your first Hello World contract and deploy it on chain. So Fatma, back to you.
Okay. I hope you can see the screen whereby we are going to
Yes.
talk about and discuss the solidity types, and there's so many, and there are many different ones. You can see how they're working and their functionalities. Yeah. So like I'm going to stress on this again. Solidity is a statically typed language, meaning that you have to define that this thing is a string or this thing is an integer, because like this language, like the compiler has to understand. So you have to specify in your code. That's why I'm mentioning that it is a statically typed language. So we're going to start looking at value types. So we have different types of value types. We have booleans and we have integers. So we're going to go through some of them. So boolean is usually like true or false value. So let's say you have specified that the greeting is hello world. So you can compare if the greeting hello world in uppercase is equal to greeting hello world in lowercase. So you can use something like a boolean to compare the two. So boolean is usually a true or false type of value. And then we also have operators. We have logical negation, uh, and then we also have like the two ands, that is an and, and then we have an or, like the two strokes. And then to look at equality, it's usually the two equal signs, and like the way when you use JavaScript, it's usually three equal signs. And then inequality is represented by the logical negation and the equal sign. And then integers, we usually have two types of integers in Solidity, but the ones that are mostly used are the unsigned integer, the uint. So there's a signed integer, which is int, and then there's the unsigned integer, which is the uint. So the uint is usually represented by the keywords uint 8, uint 2, uint 256. Like the unsigned integer of 8 up to 256. These numbers represent bits. So it's best when you're writing your smart contract. Let's say you're specifying values of numbers. Let's say you wanted to say there were 20 students in a class and you wanted to represent it as a variable. You just say uint of, let's say uint 8, and then you equate it to the number of students. And then we have operators. These are the comparison operators. This is the less than or equal to. This is the less than. And then we have the equal to. And then we have the not equal, the greater than equal to, or the greater than values, like comparison operators. And then we also have bit operators. We have the and or the or. Yeah. And then we have arithmetic operators. These are the ones that you're going to most commonly use them, the arithmetic operators and the comparison operator. So there's the addition sign, the minus sign, and then there's also the unary sign, which is only used for integers. And then there's also the modulus and the multiplication signs and the exponential ones. So these are the arithmetic operations that you're going to use mostly when you're writing your smart contracts. And then, um, so let's look at what is mostly used. We're going to look at addition and multiplication. Let's see if this is example. We'll look at an example in the next session on how you can add or multiply numbers, like how to deal with numbers in solidity. So uh, something else that we are also going to discuss is addresses. So with this solidity documentation, like there's everything you need to learn the language. Let's say even if you're trying to code as a beginner and you're stuck, this is the best resource to rush to. You see, there's everything here. So the addresses in Solidity or in the EVM and BNB type of chains, they're usually two types. Like there's the address which holds a 20-byte value. This is the Ethereum addresses that you're using, even the ENS addresses that you are using, like that are linked to your Ethereum address. They hold a 20-byte value. And then there's the address payable, which is also the same as the address, but with an additional number of members. So this address payable is the one that you can use to transfer or send a transaction, not just a transaction, but when it comes to monetary transactions, like sending Ether or sending any type of token, you can use this transfer or the send members that are in the address payable. So the idea behind this address payable is that you can send Ether, as I had mentioned. So you're not supposed to send Ether to a plain address. It has to come with a payable bit of it. So next, we're going to talk about and discuss in depth what arrays are and like how they can be used in Solidity smart contracts. So an array, uh, it's basically a data type that can be used in Solidity, like the way it can be used in any other language, like any other object-oriented language, like Python or other scripting languages, like JavaScript. They all have arrays. So mainly they're used in storage of data. Like when you have, let's say, a number of items that you want to store, you can use the arrays for storage. So usually the arrays come in fixed size bytes. So like the value types are usually bytes one, bytes two. So you have to specify the number of bytes that the array has, and then the array can be accessed by some, we call them members, but they're like more of functions. If you want to access the number of items in the array, we use this value or this member called length. So you usually specify the name of the array and the length. So we'll look into this when we look at the code a bit later. So these arrays, they usually they have sizes. So the arrays which have fixed sizes and the other arrays which have dynamic sizes. So the next thing we're going to look at, because right now we're just going through more of theory. The next thing we're going to look at is functions, like how a function is basically structured. Because when I was taking you through the previous Solidity code, I was just brushing up and showing you how it goes. So I'm going to take you through anatomy of Solidity functions. So basically, every Solidity function has two types. to start with the keyword function, like this name function, and then it has to have a function name. So the function name can be anything that is relating to what you that function is intended to do. So let's say if it's a function to send a certain amount of money, we can give it a name that is relating to it, so that even if the code is given to another programmer or developer, they can easily understand what this function basically does. So inside these brackets after the function name, that's where the parameters come in. That is the input. That is where the user is going to input data. So uint x and uint y, these are the inputs. So uint is an unsigned integer, and the uint x and uint I are both unsigned integers. But you can have inputs of different data types. You can have an input of uint, let's say uint x, and then you can have an input of a string y in the same parameter brackets. And then this part where it states public, this is where it shows the function visibility, like how the function can be accessed. So the function can either be public, private, or external. When it's public, that means it can be accessed anywhere around this contract. And then when it's private, that means there's restricted access to this function. And then when you state that the function is external, especially when you're doing the payable functions, like functions that do stuff to do with transactions or sending amounts of cash out of the contract, you can also write it as external because they're going to be called by other contracts. So this is really like a security focus on the function. So you state its visibility, whether it's going to be public or external or private. And then the view usually, like I had mentioned earlier, view indicates that this function can only does not modify the state of the blockchain. So there are different types of visibility, or yeah, like there is view, or you can also state that the function is pure. When you say that the function is pure, that means that it does not modify or read the state of the blockchain. So basically, uh, I'm not sure if Emmanuel you can share with them the link to the Solidity, yeah, the Solidity documentation, so they can also go through it as we go on before we jump into Remix. So before we jump uh, and go to Remix and see how we can put this Solidity contract, like the Hello World contract, into practice and see how we can deploy, just go to the Solidity documentation and see how we can, like, how you can structure Solidity contracts, read on the values, data types, arrays, structs. But the a struct is also like an array, but you can, you can write your own data structures. Let's say you have a struct. Let's say you have a student in class, and that student has their own properties. Like this student has a height, has a name, has an age. So instead of writing these variables separately, you can put them all, like you can compress them all into a struct. So a structure is also like treated like an array, but whereby you can have values of the same thing, which is like properties of an object which are related to that object.
Thank you very much, Fatma. So guys, I have shared the link to the official Solidity docs in the comments. So please, you can kindly click on the link and see all the resources that Fatma is referencing. Thank you very much. So please keep bringing in, sending in the comments and preparing your questions. This is a live session where we are going to deploy the code, write it first in Remix, compile it, and then deploy it.
Okay,
Back to
I
you.
hope you can see my screen.
We are still looking at the documentation.
Oh, okay. Let me share um, my remix screen. Can you see remix like on the screen?
1 second. Yes, I think now we actually can see Remix. Yes, we can
Okay.
see Remix now. Thank you.
Okay. So okay. No, no worries. Thanks. Uh, so remix is the IDE that we can use to write Solidity smart contracts, compile it, and see if there's any error or bug. If there's also going to be a small issue, it's going to throw up a warning and it's going to indicate that there's an issue. So, like, basically, we are going to use Remix. It's an online IDE, like, it can be accessed through the web. If you have the link, just visit Remix, then we start writing our smart contract. So to write a new contract, when you open Remix, there's this folder which has the name contracts. So you just right click on it and create a new file. So you're going to create a .sol file. We're going to create hello world.so. So at first it comes as an empty file. So if we want to start writing a smart contract, as I had indicated earlier, first you have to identify the license or write down the license. Most of these licenses can also be found on the Solidity documentation. So if you're not sure of which license to go with, just pick any license that is in the Solidity documentation. So let me just copy paste this contract here. So you have to write, like, for me, I chose the SPDX license identifier GPL3. This is also available in the Solidity documentation. So once you have your contract there, like it's just the same contract that I have taken you through. You can take your time to write it, or maybe I can just take you through how you can compile and deploy. So once you have your contract here, the next thing you're going to do, ensure that, just look at it and ensure that there are no errors by checking it first, and then you compile it, or you can hit Control S. So according to this, it seems like there's no error, because if there was an error, it would have indicated down here. Okay, let me just. Okay, this on the left, I'm not sure if you're all seeing this. Like on the left hand side, there's this part whereby you can see the compiler version that is being used. So according to me, I'm using 0.80. Most of the time, when you compile with a different compiler that is indicated up here, it usually throws a warning or an error. Let me just try and see if you're going to get any, because I'm using 0.80 and this is indicated here as 0.818. So if it throws an error, you have to pick a compiler version that is the same as the one that you have indicated on your contract, or you choose any that you feel is okay here. So this one is okay, like since it's on the same version 0.8. But if let's say you choose a lower version than 0.8, let's say 0.5, it's going to throw an error. So next, we're going to deploy our contract. So to deploy the contract on the BNB chain, first you have to ensure that you have MetaMask. MetaMask is the wallet that you're going to use to interact with the blockchain. So MetaMask is going to be it's going to enable you to interact with different chains. You can interact with a number of blockchains. So for us, since we are working with the BNB chain, you have to ensure that on your MetaMask, you have the BNB testnet chain there, so that you can be able to deploy it on BNB. So and then something else you have to ensure that you have is the test BNB. Like these are the test tokens that you can use to pay for gas and transactions when you're deploying your smart contract. So you have your MetaMask, you have your Binance Smart Chain testnet on, and the test BNB. So just before you deploy, you have to ensure that here on the environment, you choose the injected provider, which is MetaMask. And automatically, since I already have the BNB test chain on my MetaMask, it shows custom 97. The 97 network is the BNB test network. And then you click on deploy. Oh, it's timed out. But this is how you basically deploy a contract on the BNB chain. So even if there's a bit of an error, you can also see it down here. Like you see, like this one, it states that timeout for call deploy match data from UTAP. So this means that there's an issue when it comes to deploying this contract in the BNB chain. But this is how basically you can deploy contracts on the, like you can write a smart contract on Remix and then test it, compile it, and deploy it on the BNB chain.
Oh, okay. Thank you, Fatma. I see what that error is, and I think from my end, I should be able to like do the deployment. So, please kindly walk us through deploying here on the Remix environment and interacting with the contract, so that we can see how to like save the calls and make the calls, and then I think I would be able to like demo the deploying to the BNB chain from my PC. I think I recognize that error.
Okay.
So we can actually deploy here on Remix. Can we kindly walk us through that process, please?
Oh, like deploy. Just a second.
Yes.
Okay, so I think the interaction hadn't responded with my MetaMask wallet. So I think here it is. Let me
Yeah.
just confirm the deployment process. So basically, um, once you have your contract ready, just come here, hit compile. But let me just do something to be way safer. Let me just go back and choose the compiler version that is the same as my smart contract 0.80. Then compile it once again. I hope you can all see this.
Yes. So please note, when you are building on Remix, sometimes the compiler takes a bit of a time, especially for versions that are old. So Fatma, I think we can switch to the 0.18 compiler since I think 19 is very new and still not so compatible. So we can use 0.18 in both the
Yeah,
contract and
let me
compiler.
see.
Yes, yes.
Okay.
So we can switch to 0.8.18.
Yeah, so sometimes if you notice that you're using some of the oldest Pragma or compiler versions, just switch to some of the latest because the latest ones usually have bug fixes. Let me try to compile once again.
Yes.
Oh,
Okay.
it's compiled, I guess.
Yes.
Okay, you can now get to deploying. So as I had shown you earlier, so to deploy on the blockchain, on the BNB chain, you have to ensure that you have MetaMask installed and have some test BNB. And then when you come here at the environment, ensure that you choose the injected provider, which is MetaMask, and it will automatically pick the BNB chain if it's already there on your MetaMask. And then you just come down here and hit deploy. So I think it's already deployed, as you can see here. You see, the thing with the choosing the Pragma version, you see, earlier since I was doing 0.80, it didn't indicate the error, but when it came to deploying it, it stated some issues like I couldn't deploy it and I couldn't compile it successfully. Though sometimes it doesn't throw an error, but it will bring up some issues in the end. So it's best if you go with some of the earliest versions. Since they changed to 0.818 and the compiler also to 0.818, it now compiled and deployed successfully. So right here at the bottom left, we have our compiled contract, and there it is, our contract hello world. So we can send greeting and we can get the greeting that has been sent. So let's say hello world. Then we can set it, like push it to the blockchain. When you say set it, okay. So you can even see the process, like how the transactions are being processed on Remix. So at the moment, it's saying that the transaction is still pending. So sometimes it usually takes time. So for you to get the greeting, you just come here and call this get greetings, and you see the greeting that you sent over. So it's still pending.
I think you can call the greeting now to show that there's no response there first. So because it will come up with a zero empty greeting.
Yeah. Oh, when there's nothing. Let me try. Let me try before I set the greeting. There is nothing. But if you set the greeting, and then if the transaction goes on successfully, it's going to display the greeting that you sent through. I think basically, I think I've gone through most of the things that are required for you to run a smart contract. Oh, it's gone through. So this is how it is. Sometimes it can be kind of frustrating. You have to wait and be patient for it to go through. So let's see. I've already transacted. Let's see if I can get the greeting. Yeah, so basically that's how it is, like how to how to write a smart contract. It's basic Solidity. You write it on the Remix IDE or your IDE of choice, and then for you to compile it, like IDE, like this Remix IDE is one of the simplest to use because it's easy to compile and deploy the contract to any chain of your choice, like any chain or testnet of your choice. Yeah. So basically that's it. Those are the those are the bones, skeletons, and the structure of how a smart contract is. Yeah. So next thing we're going to look at is the Open Zeppelin library. Um, I hope you can see my screen.
Uh, I think no, it's still on the remix screen.
Oh,
Okay,
okay.
yes.
You can now see it.
Yes, we can now.
Okay, so Open Zeppelin is a library for secure smart contract development. So, if you want to build secure and reusable smart contracts, it's best if you use the Open Zeppelin library, because it implements most of the standards that are used in the BNB chains and the EVM chains. So if you want to easily implement something like a token, be it an NFT or a token contract, like let's say a coin, it's easy for you to do that if you use the Open Zeppelin library. So it has implementation standards for the ERC20 and ERC721. Like the ERC20 is the standard that is used to create tokens. Let's say like the BNB token, the the Matics, the Matic token for Polygon, the Ethereum token. They all use this ERC20 standard. So if you use the Open Zeppelin library, it's easy for you to build such things, because you just, let's say you're using an IDE, so you just do an installation of the Open Zeppelin library, and then when you're done, you can come here to the wizard. Let's say it's your first time you want to implement an ERC20 token. That is, let's say you want to come up with your own coin. Even if you want to come up with a coin for, let's say, our currency for Africa, this is basically how you can start developing it. So you can use such libraries like Open Zeppelin. So this is how basically all tokens come to be implemented, be it an NFT or a coin. So when you come here to the wizard, let's say you're not sure of how you're going to start, just come here to the wizard. There's different implementations and templates on how you can come up with different tokens. If you want to come up with your own coin or your own currency, you go to the ERC20 standards. They come up with a template on where you can start implementing it. So you can see like the way I have shown you how a Solidity smart contract is structured. So all tokens or all contracts look the same way as I'd shown you. It starts with an SPDX license, and then there's the Pragma, and then since this one you're using the Open Zeppelin library, you have to import it the same way that you import libraries in other programming languages. So for since you're using the ERC20, let's say you're building an ERC20 or your coin or currency, you're going to import the ERC20.solve from Open Zeppelin. And then there's also the contract keyword with the name of your contract and state that it's going to be an ERC20. So this is basically the structure of how it's going to look like how your contract is going to look like at the beginning. And then if you want to implement your NFT, like you want to come up with your own NFT smart contract, you go to the ERC 721 or the ERC 1155 contract. So with the ERC 1155, you can have multiple copies, but with the ERC 721, like this is how most of the like how most of the NFT contracts are made, like the ERC 721. So basically, it also has the same structure as the other contract, like the ERC 20, only that it implements the ERC 721, like it imports the library from Open Zeppelin, which is ERC 721, and like the other one, which was importing the ERC 20 contract. So basically, it makes contract development easier. So let's go back to the ERC20. The ERC20, like since we have indicated that it is an ERC20 in constructor. So basically, a constructor is an optional function that is executed when a contract is created. Let's say immediately when the contract loads, that's when the constructor function is implemented. So it usually takes in inputs, and these inputs can also be used inside the function body. So in this constructor of ours, like we say that it's an ERC20, so it usually has the token name and the token symbol. So you can also indicate it here in the wizard. Let's say you want to call it something else, like BNB Africa. we can give it that token name, and then we can also give it a symbol. Yeah, so it's easy to implement it this way. And then you can also give it other features. Let's say if you want it to be mintable, let's say if you want this token of yours, let's say so many people, you want so to give it to other people so that they can have the ability to mint it, like to create it or something. You give it this option to like so that it can be mintable. So when you just tick this option, this function automatically implements itself there. So you see, it's easier when you're using a library like OpenZeppelin to develop smart contracts, be it an ERC20 that is a coin, or be it ERC721, an NFT. So you can give it all these properties. When you say ownable, that means that you're giving it access control, that maybe only a certain number of people or some a certain person is the one who is going to have total control on minting and transferring of this contract. Yeah. So the license can also be specified here. So you see MAT. That's why the license identifier here is indicated as the MAT license. So you see, it's way easier when you're using something like OpenZeppelin. So you see, once you're done creating your contract here on this wizard, you can then copy paste it if you feel like, or you can create it afresh and deploy it on Remix the same way I have shown you how to deploy the previous Hello World smart contract.
Awesome. Awesome. Uh, that was awesome. Thank you
Yeah,
very
so
much.
welcome. So that's basically it. Those that's how a smart contract is structured. It's no different from the other Web2 languages, only that it has a bit of protocol whereby you have to specify licenses and the pragmas and all that. But according to what you've seen and tested, it's really simple to write Web3 applications or blockchain applications. I hope you enjoyed this session.
Yes, we did. Thank you very much, Fatma. So, thankfully for us, these sessions are built to last for a 90-minute period. So, I suppose we still have a bit of a time to take questions from those who are here in attendance. And yes, would have this video available for everyone who is here, so you can always rewatch in your free time and then get to go over the things that you may have missed during the course of the live session. So, if you have any questions while we are still here, I would want you to drop them in the comment section. And also, I would like to get a sense of your real time feedback. For those who didn't join us at the beginning, I did mention that based on the feedback from last session, that we'll be having a session on security and understanding a whole lot more about the infra, and and also if you have any other sessions in mind that you want us to um, share knowledge on and bring experts to come talk to you, either internally from BNB or experts from across Africa, we would be able to bring those, have those sessions. So, like I mentioned, while we are still here, if you have any questions, but while we are waiting for those who have questions to give us questions, please drop your feedback on how today's session has been for you in the comments. And I can see a lot of our regulars here joining us this evening. It's a delight to have you guys here with us. uh, Daniel, Nicodemus, Rachel, Justice, Obayemi, uh, Twite Space, Rex, Delgado. It's a pleasure to have you. Majesty, it's a pleasure to have you guys here. So while we are waiting for questions to come in, I think I'm just going to read some comments that we have here. Oh, a lot of hellos. Nicodemus had asked earlier, he wants to use VS Code Solidity as a plugin. Okay. Um, Thank you, Victory, for that feedback. Thank you so much, guys, for all the feedback. So, guys, we are just going to wrap it up here, but please remember that we have the Telegram link for those who have not joined. So we have the Telegram link for those who are not joined us on Telegram. It's a channel strictly for developers in the African region, right? And you have Fatma in there as well, so you can always ask questions, and then rest assured we'll be able to provide real time feedback. So here is an exercise that I want to leave you with. So, guys, next week we are going to be going deeper into smart contracts, right? And then, as a way of expressing what you have learned today, I would want you to go to Open Zeppelin, um, write a contract using the Open Zeppelin wizard, bring that contract to Remix, compile it, deploy it on BNB Chain, right? And then send the address to the contract in the Telegram channel. And there is a reward for those who get to carry out that exercise. So again, I'm going to say the exercise is very simple, right? You go to the Open Zeppelin contracts wizard, um, come up with a contract there, take the source code for the contract, bring it to Remix, compile it, right, deploy it to BNB chain, and then take that contract address that has been deployed, bring it to us on Telegram, and also make a Twitter thread about the process, tagging BNB chain, and then using the hashtag BNB chain Africa, using the hashtag BNB Chain Africa, right? And also tag us on Twitter. So again, I say the handle on Twitter is BNB Chain, and then the hashtag on Twitter it's BNB Chain Africa, right? So again, once you have deployed your contracts on Remix, from Remix to BNB Chain, take that contract address, share it with us on Telegram on the BNB Chain African Developers channel, right? No, on testnet, of course, on testnet. Thank you, Obayemi, for that important question. On testnet, right? Write a thread on the process, mention BNB Chain in the thread, and then hashtag BNB Chain Africa. So again, I'm going to repeat. Go to the Open Zeppelin's contract wizard, create any contract using the wizard, bring that contract to Remix, compile it, deploy it to BNB chain testnet, take the deployed contract address, and then share it with us on Telegram, and also do a thread on Twitter, right? And also share that Twitter thread on Telegram as well, because we will be monitoring those who deployed and those who we'll be monitoring those who deployed and those who wrote the thread, right? So yes, Daniel, I just shared the link in the comments to the Open Zeppelin Wizard Docs, right? So we'll be monitoring those who deployed and those who wrote a thread. So share both things on the Telegram channel. I mean, you have between now and next week Friday to pull up the stacks. It's a delight to have you here with us. Thank you all of Africa for joining us. And Fatma, just before we go, what is your advice for those who joined us today and what would be your words that you leave them with to inspire them?
Okay, so well, one thing I'd like to advise you is that learning is a process. So don't give up. The number of resources online, it's not like how Web3 was at the beginning. And there are many communities you can join and learn from others at the same time. There are also some nice courses like Alchemy University is offering online courses on how to do smart contract development. We also like here with BNB Africa, like with BNB and a platform provided by Emmanuel for Africans to learn. So, like when you hear of such workshops and online courses being provided, don't shy away from taking them. So, it's very important to take a couple of them and try out to build on your own and never give up. Yeah.
It's important to try and build on your own and never give up. Thank you so much, Fatma, for those inspiring words. And on that note, I say thank you, all of Africa, for joining us this evening. Same time next week, where we'll be going deeper into smart contracts. I look forward to having a session with you then. Bye. And remember the task for today. Write your contracts, um, take it from the wizard to remix, compile it, deploy it on BNB testnet, take the contract address, write a Twitter thread about it, and then submit that Twitter thread and the contract address. And rest assured, these things are time stamped, so we'd actually know if you perform this task between now and next week Friday. And yes, there's a reward waiting for all those who will perform that exercise. Look forward again to see you next weekend. Thank you once more, Fatma. Bye, all of Africa. Good night.